Okay, let's go to page 54, and this is lesson 5.2. This deals with ellipses. Okay, so ellipse, the definition of ellipse is you have two, so the one point is called a focus, and two, the plural form is focuses or foci. Okay, now the definition is the sum of the distance to the 2 points is equal to constant. So d1 plus d2 equal to a fixed number, and its distance is 2a. Okay, so d1 plus d2 equal to 2a. Now also, when you have ellipse, this is called a vertex for the major axis, and this is the B. This point is the B, and this point is the focus. This point is the focus. Okay, and this is the center. So this distance over here is a small b. This distance over here is the c. And in an ellipse, the biggest number is a. Again, a is your hypotenuse. So a. So in this case, a squared equal to b squared plus c squared. Okay. And what's a? Well, a is this distance right over here. So that's your a. Okay. So in other words, if you slide this down, it would be from center to the vertex. Okay. And you can see that from here. If you move this point to here, then you're going to get here. So here's your D1, and here's your D2. And notice this D2, if you move the D2 over here, this would be also the D2, right? Because it's symmetrical. So you can see that D1 plus D2 equal to 2a, because this is your a, this is your a. Right? Okay? Okay, now with all this information, now we can go ahead and get the standard form for the equation. So you got x minus h squared over a squared plus y minus k squared over b squared equal to 1. Okay? So h and k will give you the, okay, but by the way, this is called a major axis. This is the minor axis. Okay? So 2a is your major axis, 2b is a minor axis. Okay, so a is always the biggest number, so because the biggest number is under the x, so the ellipse is going this way. Okay? Now if you have x minus h squared over b squared, if the bigger number is under the y, if the bigger number is under the y, that means the long axis is the bigger number is the long axis would be in the y direction, so it would be like this way. Okay. Okay, now on page 56, there is another term. So if you go to page 56, on the very bottom, there's a term called eccentricity on the very bottom paragraph. And eccentricity is E. Now this is not the natural log base E. Okay, this is just eccentricity, and this is equal to C over A, the ratio of C over A. Okay. Also, let's go over here. So eccentricity equal to C over A. Now, if you know a circle with a radius of r, the area of the circle equal to pi r squared, right? R times pi. Now for ellipse, you're going to have an A here and B here. So the area of an ellipse is equal to pi AB, right? It's just the same way. So a circle is a spatial ellipse. Okay, so again, area of the ellipse is just pi times, you can call it this radius and this radius. Okay? So again, very easy to remember, just like the circle. So you can see where this came from, right? Area is pi times this radius times this radius. But in the ellipse, they are different. So that's why they are different later, okay? So again, circle is a spatial ellipse. Okay, and so let's go to example 5-8. Example 5-5. Okay, it says graph and find the center, foci, area, and the length of the axis of ellipse given by, you got 9x squared minus 36x plus 4y squared minus 24y plus 36 equal to 0. So first thing you want to do is you want to get rid of this number and you want to group your x and y to complete the square for x, complete the square for y. Okay, so minus 36 on both sides. So basically all we're doing right now is complete the square. Now you're going to group your x together, leave a space because that you're going to need a number to complete a square, and do the same thing for y. Okay. Your next step is you need to go and factor out the coefficient before the square. So factor out the 9. This one you have to factor out the 4. So factor out the 4. Your next step is go and complete the square. So get your template ready. Okay, so that's your template. Okay, so now what we're going to do is let's go and complete a square. So from here you need to have an x minus 2. Okay, so since to get a minus 2 over here you need to get plus 4, right? Because negative 2 squared is plus 4. So you need to have a 4 to complete a square. Okay? And notice there's a 9 times in front, so 4 times 9 gives you 36. So you need to plus 36 on this side to even it out. Again, whatever you do on this side, you have to do on this side. And because it's a 9, so when you plus 4 times 9, that's 36. So you have to plus 36 on this side to even it out. Okay. Now for the y, you need to get y minus 3. Okay? That means you need to plus 9 over here. Now you have 9 times 4 is also 36. Now usually the numbers are different, okay, but in this case they just happen to be the same. So this cancels, so you get 36. Now your next step is you have to divide this so that it becomes 1. So divide by 36. Usually this number will crisscross, okay, usually. Not always, but usually. Okay. So this will cancel, so you got x minus 2 squared over 4. Again, see the number cross over. Okay, and this would be y minus 3 squared over 9. Right, cancel out, right? Equal to 1. So you want to, so that's your standard form. Okay, that's your standard form for ellipse. So that is your form right over here. Okay, so since this number is bigger, so you know that the ellipse is going to be in the y direction. Okay, so let's go and sketch these things out. Okay, so first you have to do is get your vertex. So from the vertex you can see that it's going to be at 2, 3. So vertex is going to be, center. The center is going to be at 2, 3. So for ellipse, your key point is your center. So go and get your center. So it'd be 2, 3. So that's your 2, 3. That's your center. Okay, then from here, again, bigger number is your a square. So this is a square equal to 9. So a equal to 3. Over here, the b square equal to 4. So b equal to 2. Okay? So what it tells you that you have to go 3 in the y direction because this is under the y, so you have to go 3 in the y direction. Okay, so right over here and you go down 3. So that's your V. Okay, so your V in this case, so it's already 3, so you go up 3. So this would be a 2, 6. So learn how to follow the path. So when you go down is Y, right? So the X will not change. When you go up and down, the Y stay the same. But when you go down, you have to minus. So 3 minus 3 will give you 0, okay, which match, right? Again, start with the center. You have to go 2 in the X direction. Okay, so your ellipse is going to be like this. And so this is the B. Again, you start with, so when you start at the 2, 3, so again, that's your key point. So start at 2, 3, and you go this way by 2, so it becomes 4, 3. When you go this way, you have to minus 2. So again, when you go sideways, the Y stay the same. The Y stay the same. The X, so you start at 2, right? You go 2 this way. So when you go this way, you have to minus. So 2 minus 2 give you 0. Okay? Okay, so let's go back and answer the question. So you found the center. Okay, you found that. Okay, you need to find the 4 sides. So you need to find the F. So to find F, you need to get C, right? Again, remember your Pythagorean theorem, okay? And A is the biggest number, so A is your hypotenuse. So A squared equal to B squared plus C squared. Okay. So A squared is 9, B squared is 4. So C squared equal to 5. So C equal to square root of 5. Okay? And we're not worried about the negative, because plus or minus, because C is a distance. So once we know the distance, we can use that. Again, when you go up, the X stay the same, right? Again, everything is focused, everything is all based on the center. So start from the center, so you go up, the X stay the same, the Y will increase by this distance. So it becomes 3 plus square root of 5. This one, again, when you go up and down, the X stay the same. When you go, so you start at the center, and you go down, you have to minus. So start at 3, you go down, you minus by the distance over here. Okay, so that's how you figure out the focus. Okay, and now you have to find the area and the length of axis of the ellipse. Okay. Okay, so A is 3, so 2A equal to 6, and B is 2, so 2B equal to 4. So this is the length of the major axis. And this is the length of the minor axis. Okay? And to find the area, K equal to pi AB. So K equal to, A equal to 3, B equal to 2. So it would be pi times 3 times 2. So area equal to 6 pi. And go back and answer the question. Make sure we answer everything. Okay, length of axis, and yeah, that's it. So that's everything. Okay. Okay, let's go over a couple more examples. Let's go to example 5-6. Example 5-6. It says, what are A and B for the ellipse? So you got 4 times x minus 1 squared over 9 plus y minus 2 squared over 8 equal to 1. Okay, to find A and B, we have to put this in a standard form, but notice there's a number right over here. Okay? So there's a number over here. We have to get rid of the number. So we need to multiply by 1 over 4, 1 over 4. So that this will cancel out with that. So your equation becomes x minus 1. Again, you cannot have any number over there. Okay? So this is 9 over 4. Okay, so now once you have standard form, notice this number is bigger than that. So that's your A squared. That's your A squared. So A squared equal to 8. And the B squared equal to 9 over 4. So take the square root. So A equal to square root of 8. So A equal to 2 square root of 2. And take the square root, so you get B equal to 3 over 2. And so those are your A and the B. Okay, and that's it. Okay. So you can, this is very tricky because if you don't pay close attention, you think, oh, this is bigger number, so this would be A, so A equal to 3. No, that would be incorrect because that's a 4 right over here you need to get rid of. Okay, let's go to the next example. Example 5-7. Okay, it says find the ellipse with a major axis length 8. So major axis is 2a. So 2a equal to 8. So right away a equal to 4. And the center is at 2, 1. And one focus at 2, 3. Okay. Again, the best way to do the conic section is sketch it out. Once you have a picture that you can see, and it will make things very easy and very obvious. Okay, center is a 2, 1. And focus is a 2, 3. Okay, so this distance right over here, that's your C. Okay, so from here you can just look at the graph and or just look at numbers. So from 1, so you're traveling from 1 to 3 will give you 2. Okay, so in this case C equal to 2, and A equal to 4. Now since F is always on the major axis. So here's your F. That means the V will be up here. So 4. Again, when you go up and down, it's y, right? So when you start at 1, you go up 4, it will give you at 5. Okay, so it's going to be right over here. So this would be your V, and it's going to be at 2, 5. So your graph is going to be like this. Okay, so again, center is over here. So A is 4, so you go down 4. So 1, 2, 3, 4. So this is another V right over here. And if you do on a graph paper, it make it even easier. Okay, it's even more obvious. So this would be 2, -3. Okay, okay. So now you got an A, you got a C, you can find B, right? So A squared equal to B squared plus C squared. So A is 4, so A squared is 16. B is what you're looking for, and C squared is 4. So B squared equal to 12. Okay. Now this one, they ask you for equation, so you don't even need to complete the equation. Okay. So let's go and let's go and get a template ready. So you're going to have something square. It's always x. I like to put x first. So plus something square equal to 1. Okay. Okay, the center is at 2, 1, so it'd be -2, -1. Okay? A is 4, so A squared is 16. Now you have to be careful now. The long axis is in this direction, so this has to go under the y. Okay? So 16 go under the y because the major axis in the y direction. So that means the minor axis will go to the other one, which is right over here. Again, notice I don't even need to solve for B. Okay, because this is the B square, so I put over here, and that's it for this problem. Okay, so once you sketch it out, you can find a relationship between all the points, and you can find out your A, B, or C, or whatever you need to get. Okay. Okay, let's go to the next example. Okay, example 5-8. Okay, it says, to give my dog some space to run, I drove 2 stakes in my lawn 10 feet apart. Okay, so 10 feet apart. And I tie ends of a 30-foot rope to a stake. So the rope is going to be loose, right? So it's going to be like, and the dog is going to be over here. Okay, the dog, it had the collar is kind of tied to the rope, and so that's your D1, D2, and it tells you that the rope is 30 feet. So that means D1 plus D2 equal to 30 feet, and that's equal to 2A. Okay, again remember D1 plus D2 equal to 2A, right? So from here you can see that A is equal to 15, and by the way, when you loop this thing around, okay. That's how you get ellipse, okay? See, when you have a circle, you have the center, right? And you kind of go around that dot, you get a circle. But when you have two dots, you go around that, you're going to get ellipse, okay? So from here you can see that the center is going to be over here. So in this case, C equal to 5, okay? So you need to understand what those things try to tell you. So C equal to 5. Okay. So you're looking for the area, okay? Okay. So to find the area, you need to find B. So A squared equal to B squared plus C squared. So A is 15. So A squared would be 225. B squared plus C is 5. So squared will give you 25. So B squared equal to 200. And so B will equal to square root of 200, which will equal to 10 square root of 2. Okay? And so you got you got B here, you got A here. So your area equal to pi AB. So it'll be pi times A is 15, B is 10 square root of 2. So area equal to 150 square root of 2 pi. Okay? So in this case, you don't even need to bother to to find the equation of the ellipse. Okay? Because all you need is find A and B, then you can get the area. Okay, on page 60, right below the example, it says keep an eye out for this slick application of the constant sum of distances properties of ellipse to the parabola. So you can, just like a parabola, is sometimes you have applications. So like you talk about slide something under the arch or whatever. So in this case, it's like there's a tie a dog to a rope and you can roam around in the elliptical area.